Hello, Algebra 2 friends, and welcome to class. Today we're on lesson 24A, and we're going to talk about graphing parabolas. So, as you're probably going to see, there's a pattern when we graph. When we have x squared, so when we have y equals x squared, we can take the largest exponent and subtract 1, and that'll tell us how many bumps are in our graph. So in this case, there is one bump, so it's going to be a parabola. So every x squared equation, we could have stuff after it too, and we're going to be graphing those equations later. We're keeping it simple by just having one term in our equation. But any x squared equation is going to be a parabola. So a parabola facing up or a parabola facing down. These are also projectiles. So when you throw a ball, it goes in an arc. And um, whenever the opposite of the arc would be like a little smiley face. So those are parabolas, and they're always going to be x squared. So x squared is the largest exponent, then we're going to be graphing parabolas. So in any graph, you can always plug in points and make a table next to you, and that will always give us some x coordinates and some y coordinates so that we can graph it. The trick is finding the coordinates that make the most sense. So that's all we're going to do here. We're just going to take some x coordinates and some y coordinates, and we're going to go ahead and plug them into our equation, see what we get, graph those, and connect the dots. That's all we're doing for this assignment. Very simple. I just want you to start recognizing some patterns of how you know if the graph is going to open up or if it's going to open down. And there are, of course, math rules to go along with these, but instead of just memorizing the rule, it's great if you can recognize the pattern yourself. Okay, so let's get started. So on each of these problems, we are going to make an XY table, and this is going to help us know where to graph. So if I plug in X, what do I get for Y? So I'm going to write everything out so it's very easy to see what I'm doing, but you are more than welcome to do these equations in your head. As you get better and better at math, you'll be more efficient if you can go ahead and do some of these things in your head. But for now, it's okay if you want to write them down, and I'm going to write them down to show you exactly how I'm getting all of these values. So we have Y equals 3, and I'm going to plug in my 0 for X because I want to know when X is 0, what is Y going to be? 0 for X, and we're going to square that. Okay, so 0 squared is 0. So then I have 3 times 0, and that's going to equal 0. So that means when X is 0, Y will be 0 too. So I could write Y's down here. Remember, mathematicians really like to be the most efficient. So like I said, you could have done that in your head, and that's fine. But I just wanted to show you so you knew exactly what I was doing. So I fill in 0 for my Y value. Okay, now I'm going to, I always like to go with 1 and -1 so we can see what's happening with our graph. So if I plug in 1 for X, I get Y equals 3, parenthesis, 1 squared. Okay, now we have to do exponents first. So remember the order of operations, that PEMDAS, or please excuse my dear Aunt Sally, or some people like to say PEMDAS. Exponents come before multiplication division. So we do our exponent first. 1 squared is 1. 3 times 1 is 3. So Y equals 3. So when X is positive 1, Y is going to equal 3. How about when X is -1? I want to know what's happening on this side of the graph as well as on the negative X side of the graph. So Y equals 3 to the -1 squared. Now, some of you already looking at this, you can tell what it's going to be, but we're going to walk through it slowly. Negative 1 squared is positive 1. Positive 1 times 3 is 3. So y will equal 3 when x is negative 1. Okay, now I want to see what the graph is doing, not just close to 1 and 0, because I'm only right here. So I want to see what it's doing when I get more out here. So I like going with 5. 5 is usually a nice round number. 1, 2, 3, 4, 5, and that kind of puts us more on this side of the equation. So I'm going to do positive 5 first, and then I'll do negative 5. So I'm going to go up here so I can save room down here for my other equations. Y, let me fix my paper here. Y equals 3 times positive 5 squared. So 5 squared equals 25. 25 times 3 is 75. So what about when y is negative 5? So negative 5 squared is positive 25 times 3 is 75. Now, I don't have 75 in my y value. So I'm not going to be able to graph this point. And I really want 5 points when I'm graphing parabolas, especially when you're starting out. So I'm going to choose 2, even though it's still closer to 1 than I'd really like. It's going to give us more of an idea. So we're going to go with 2 and negative 2. So y equals 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. Okay, and we're going to go ahead and be more efficient with math now. Now that we've kind of seen a little pattern going on here, we can be more efficient. So in my mind, I could put negative 2 there. Negative 2 squared is still positive 4. And then 4 times 3 is 12. Okay, so now I have some points I can graph. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to make some marks so I can estimate where 12 is. Okay, so negative 2, positive 12 is negative 2, positive 12 up there. Positive 2, positive 12 is over here. I can't graph this 5, negative 5 because I don't have 75. I won't have enough room even to add marks on my paper. Then positive 1, positive 3 is over here. Positive 1, positive 3, and then negative 1, positive 3 is right here, and then 0, 0. Okay, so now we can just connect our dots. And we're trying to make a smiley face, if you will. We're trying to make a parabola. So we always put arrows on our graph because this graph is going on forever off of the paper, but this is just our little sketch of the graph. Okay, so that's all we're doing. This is easy peasy math, right? We're just looking at our equation, figuring out what points we want to plot, and then we're just plotting those points and drawing our graph. Okay, we're going to make our XY table again. First one I like to start with is always 0. Now I'm going to do this one in my head. If I plug in 0, 0 squared times the negative 1 is going to be 0. Okay, so let's do 1 and negative 1. y equals negative, parenthesis, plug in my positive 1, and I square it. Okay, so negatives are always tricky in math and can always, if you approach the negative wrong, then you will get the wrong answer. So you need to make sure you go through the steps very rigidly. 1 squared is positive 1, and then I multiply the negative 1. So I have negative 1 because I already applied the squared, and then negative 1 times a positive 1 is negative 1. Okay, so y equals negative 1 when x is positive 1. Okay, same thing. Y equals negative, parenthesis, negative 1 squared. With my PEMDAS, I always do the exponent first. Negative 1 squared is positive 1. A negative times a positive 1 is negative 1. So even when x is negative 1, y is still negative 1. Okay, so on this one, I really think we can do 5. Positive 5 and negative 5. Y equals negative positive 5 squared equals 5 squared is 25, negative 25. Actually, that's not going to fit on our graph, right? So I'm just going to scratch those out. Let's try 3 and negative 3. Y equals negative positive 3 squared. And that equals 3 squared is 9 times a negative. That equals negative 9. Negative 9. Y equals negative 3 squared. Negative 3 squared is positive 9. Positive 9 times this negative out here is negative 9. So that's still negative 9. Okay, now I can graph my points. So 0, 0, 1, negative 1, 1, negative 1, negative 1, negative 1, negative 1, negative 1. And now I have positive 3, negative 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I need another mark here. 9. And then I have negative 3, negative 9 over here. So that's what our parabola looks like there. So if you look at these two equations and these two parabolas we've drawn, you might be able to recognize a pattern when our equation, the first term that the x squared is on is positive. What happens to our parabola? It opens up. And then when we have a negative in front of our x squared term, it opens down. So that's just a little hint. Okay, let's make our XY table. And I notice that I am going to be dividing by 3. It's really helpful if I can come out with whole numbers to graph with, because this graph is really small and it's hard to split each of these individual lines up into thirds. So because of that, I'm going to pick numbers that are going to be divisible by 3, just to make it easier on myself. Okay, so the first one, 0. And when I plug in 0 for x, I get 0 squared, which is 0, times by a 1/3. 1/3 times 0 is still 0. Okay, I'm not going to plug in 1 here because I know I'm going to be dividing by 3. So I need to make it a little bit easier on myself. And I'm going to pick 3 and negative 3 to work with. So y equals 1/3. And I know the computer writes it like this. Sometimes it will write it like this. When we write it in math, we always write the fraction up and down. We never write it like this because it's hard to tell from our handwriting what is the numerator and what is the denominator. This is a formatting error, really. And in the modern, I think Matthew C was written a long time ago. In the modern computers, they can write them like this, and this is the more correct way to write it. If I ever saw a student writing it like this, so it's all in the same line, it's just a lot harder to tell what's the numerator and denominator, and I would have them rewrite the equation. So whenever you see a fraction that's written like this on the same line, that's just a computer formatting issue. And we want to make sure that when we write it in the correct way. Parenthesis, because I'm plugging something in, and I'm going to plug in my 3. And then it's squared. So make sure we write squared. Okay, exponents first. So 3 squared equals 9. So 1/3 times 9. The 9 will cancel with the 3, and I'm left with 3 on top. So y equals 3. So when x equals +3, y equals +3. Okay, let's do the -3. 1/3 times -3 squared equals -3 squared is +9. 9 divided by 3 is 3. And so it's still 3. Okay, so let's do another number. I'm trying to think. So let me think out loud so you can think with me. 4 squared is 16, and 16 is not divisible by 3. So actually, that's not going to help me. 5 squared is 25, which is not divisible by 3. 6 squared is 36. If I divide 36 by 3, that's going to give me 12, right? So 6 is going to work better for me here. So I'm going to write 6 and -6. So y equals 1/3 +6 squared. So 6 squared equals 36. So then I have 36 divided by 3. 36 divided by 3 is 12. And now you can do the shortcut because we've done enough to recognize the pattern. If I put in a -6 here, nothing changes because I'm squaring the number, so I still get a +36, and the steps are the same. So I have 12 there too. Okay, so I have 0, 0. Then I have 3, +3, +3. 1, 2, 3, 1, 2, 3. I have -3, +3. 1, 2, 3, 1, 2, 3. And then I have 6, +6, +12. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So not incredibly exact, but it's still better than not getting that fourth and fifth point. 1, 2, 3, 4, 5, 6. Let's go ahead and graph this one over here-ish. And then 1, 2, 3, 3, 4, 5, 6 over here too. Okay, so now let's try to draw a curvy line, which is always really hard, but it goes something like that. Okay, again, we had a positive equation. The first term is positive, and we have an opening upwards parabola. Okay, and if you notice, on all of these equations, we only have one term. And what do you notice that is the exact same? So we have one term in all of these 3 equations. That means I don't have plus 3x plus 6. I don't have anything extra hanging around. So I have one term in all of these equations. They're all parabolas. What else do you notice about these graphs? That they are all the same. The vertex, the point at which the graph radiates from, the vertex is 0, 0. So that's a little hint too. So noticing patterns is a big part of math. Okay, now we have x equals 4y squared. Okay, I'm going to want to choose little numbers because even I'm going to square some number and then I'm going to multiply by 4. So I'm going to get really big numbers. So I have my xy table. And my first point is going to be 0, 0. If you notice the pattern, then you can just write down 0, 0. And then I have positive 1 and negative 1. Let's figure out what those are. So oh, this is x equals. Okay, so we do need to solve for y here because we cannot, well, we could plug in points. So we'll just do that. We're going to plug in positive 1 for y and negative 1 for x. Just clean this up here. When I looked at that equation, I did not notice that right away. So now we are plugging in stuff for y and we are solving for x. So that's quite a bit different. So we have x equals 4 times 1 squared. So when y is 1, what is x? 1 squared is 1 times 4. So x is equal to 4. If you notice the pattern, we can already input our negative 1 and notice that nothing changes. Everything stays the same. So now we're going to try 2 and negative 2 and hope it doesn't get too big. 4 times positive 2 squared. 2 squared is 4. 4 times 4 is 16. Kind of big there. And if you notice the pattern, you can go ahead and write down 16 again. Okay, so we have 0, 0, and then we have 4, comma 1. 1, 2, 3, 4, comma positive 1. And then we still have x is equal to positive 4 and negative 1. And then we have x is equal to 16. 9, 10, 11, 12, 13, 14, 15, 16. And y is equal to positive 2 and negative 2. So it looks something like that. Remember, this is a sketch. It doesn't have to be completely exact. So when we have x is equal to y squared, look what happened to our parabola. It kind of turned on its side. Okay, so we have XY chart again. We have that x equals the y squared, but we also have this extra stuff. So we don't just have one term. So let's plug in 0 for y and see what we get for x. Let's see what happens. So x equals negative 3, parenthesis. We're going to plug in 0, and then we're going to square it and add 1. 0 squared is 0 times negative 3 is still 0. And then we're adding 1. So 0 plus 1 is 1. So x equals 1. Okay, so how about we put in positive 1 for y? Positive 1 and negative 1 into our input. So x equals negative 3 times positive 1 squared plus 1. So always go back to your original equation and make sure that you wrote everything down and you didn't miss anything. It's always good to double check. 1 squared is 1, positive 1. Positive 1 times negative 3 is negative 3. Negative 3 plus 1 is negative 2. So x equals negative 2. So when y equals positive 1, x equals negative 2. How about when y equals -1? -3 times parentheses, -1 squared plus 1. -1 squared is +1. +1 times -3 is -3. -3 plus 1 is -2. Okay, so I really want another point here. We're not getting so big of numbers, so I'm going to try my 5 and -5 for y. +5, -5. Okay, let's see what we get. X equals -3 times +5 squared plus 1. 5 squared is 25. Oh no, we did get a really big number. So let's not do +5. Let's stick with 2, +2 and -2 to see if we can get some numbers on this graph here. Okay, 2 squared is 4. 4 times -3 is -12. -12 plus 1 is -11. So when y is +2, x is -11. Okay, and then we can just write down our -2 and notice the pattern. Nothing changes, so we still get -11. Okay, so let's start our graph 1, 0. So 1 in the x direction, 0 in the y direction. And then we have -2, +1, -2, +1, -2, -1. And then we have -11, 9, 10, 11. -11, +2, -11, -2. Okay, and then now I'm going to draw my parabola here. Okay. So notice what happened when we had x equal to y squared. When the y is being squared, our parabola flips on its side. And when we have -y, it goes to the other direction. Just some things to notice. Also, when we had some extra stuff out here, our graph shifted. Okay. All right, now we're back to normal with our y equals x squared. So let's make our xy table. Plug in 0 for x. What do we get for y? We don't just have one term, we have two. So it's going to shift. So when I plug in 0 for x, I'm going to have a -4 for y. Now let's go ahead and plug in +1, -1, and I'm going to do +2, -2. Y equals +1 squared minus 4. 1 squared is 1. 1 minus 4 is -3. And if you notice the pattern, then you can just write down -3. Again, y equals +2 squared minus 4. So 2 squared is 4. 4 minus 4 is 0. -2 squared is 4, +4. 4 minus 4 is still 0. Okay, so now we can go ahead and plot our points. 0 in the x direction, -4 in the y direction. Positive 1 in the x direction, negative 3 in the y direction. Negative 1 in the x direction, negative 3 in the y direction. Positive 2 in the x direction, 0 in the y direction. And there's our points. So it's going to be wide like so. And there we go. So remember, it's not a V shape. This really is a U shape, but I am not great at drawing. Okay, so that is it. And notice we had a shift in our vertex because we didn't just have one term. So it did shift down when we had a negative 4 term there. All right, great job. And I'll see you next time. Bye.